Periodic tables, one of the best tools you're going to use this year in your learning of chemistry, and so we're going to just look over it briefly and explain some of the information that it gives to us. We'll go much more in depth in Chapter 5. We have an entire chapter on the periodic table. But for now, we're just going to learn some basics. For example, the reason we call it a periodic table is because each horizontal row is called a period. And there are a total of 7 periods in the periodic table. The top period, period number 1, contains just 2 elements, hydrogen and helium. And then as you go down the periodic table, you go period 2, period 3, period 4, all the way down to period 7. The vertical columns are called groups. And there are 18 groups in the periodic table. Starting on your left is group number 1 and group number 2, and then all the way on the right is group 18. Every element placed in a group is placed there because they have similar properties, and because they have similar properties, we also call these groups families. Just like people and families have similar properties, the elements in these families have similar characteristics such as melting point, boiling point, density, and maybe some chemical properties. The periodic table is divided up into 3 general categories: metals, nonmetals, and metalloids. And so looking at this periodic table down at the bottom, the yellow elements are all considered to be metals. The green elements are nonmetals. Now in between metals and nonmetals we have a sort of stair-step line that you'll see on most periodic tables that kind of divides the metals to the left and the nonmetals to the right. Those few elements that stagger that line we call metalloids, and they contain properties of both metals and nonmetals. But most of the elements on the periodic table, about 2/3 of them, are metals. And as you can see here, certain groups have specific names. For example, group 1, we call those the alkali metals, and these are the most active metals. Group 2 we call the alkaline earth metals. The groups 3 through 12, those are called the transition metals, because as we move left to right, we're transitioning from metals to nonmetals. And then we go over to group 17, which we call the halogens. These are the most reactive nonmetals. And group 18 we refer to as the noble gases. These elements are unreactive. They are inert. They don't react with any other elements. And so we call them noble gases. And then those elements that you see down at the bottom, across the bottom of the main periodic table, those are called the lanthanides and the actinides. And we're going to talk more about those when we get later on in the course. Of course, we're all familiar with metals. Metals are good conductors of heat and electricity. We use them for wiring. We use them for pots and pans on the stove. They conduct heat and electricity, and it has to do with the way their electrons are bonded, that we'll talk about later on in the chapter. But just for now, know that they're good conductors of heat and electricity. They're malleable, and malleability means that you can pound out a metal into a thin sheet. We can shape it. They're also ductile. It means we can pull it into a wire. That's why a lot of wires are made from metals. And they have a high tensile strength. Metals can support a large amount of weight compared to their weights. So we use them in cables for bridges. And they have luster. Metals are shiny. They reflect light and can be used for things like jewelry or ornaments, as well as safety reflectors. And then here's just some examples of metals. There are some soft metals like potassium, which we probably don't think about as a soft metal. Then of course copper and zinc we're familiar with. Mercury is the only liquid metal that exists at room temperature. All the other metals are going to be solids at room temperature. And then the nonmetals on the periodic table, like the right-hand third, they essentially have the opposite properties of metals. Nonmetals are poor conductors of heat and electricity. They tend to be brittle, and you know that because your pencil lead is made of graphite, which is a nonmetal, and those break quite often because they're brittle. A lot of nonmetals are also gases at room temperature. Of course, all the noble gases are gases at room temperature, and some of the halogens, such as fluorine, chlorine, are gases, as oxygen and nitrogen are as well. And here are some pictures of nonmetals. This is sulfur and phosphorus, and of course a diamond, which is also made out of carbon. Carbon can exist in a few different forms, one of them being diamond and the other one being graphite. And then those metalloids that stagger that stair-step line. Metalloids have properties of both metals and nonmetals. And one of the most important characteristics of metalloids is that they are semiconductors of electricity. And we use semiconductors in computer chips, which of course are in computers, but are also in cell phones and car engines. And metalloids are probably the most important group of metal to our technology lifestyle. Silicon's one of the most important metalloids, and we probably covered a lot of this in the previous slide, but silicon is what they use for computer processing chips. And here's a list of the other metalloids as they stagger that zigzag line.